think, okay, keep talking real quick again.
How's the volume now?
I think it's good. I think we're good.
Okay.
Do you guys,
Yeah.
is that good for you guys? I feel like that's good.
Yeah, you don't want to. I can get loud and boisterous, so you never know just how to set my volume.
Yeah, I think actually that's perfect now.
Okay.
I think it is. Everybody in chat
We are
will.
normalized.
We
then.
are finally. So how have you
Yeah.
been?
Good. How long has it been since we've hung out in this venue?
In this capacity, it's been a while.
Yeah, it's been several months.
Yeah.
For sure.
Oh yeah, I
So,
think like a half a year.
yeah. And it's funny too, because I'm sure, like, I don't know about you, but just life gets crazy busy, and so if you don't have it scheduled, if you don't carve out time in your schedule for it, then you just live.
Yeah, and
So
that's pretty much how it's been. So it's been pretty annoying. Life has been pretty annoying, but I shared some of that already with you. So
yeah. Man, I know the feeling. It's
yeah,
just like adulting is rough.
it's super rough. It is
So
so rough.
yeah, and so like any of those of you out there who perhaps haven't reached the age of adulthood yet, and you're just, I don't know, thinking you've got it tough, just wait.
Just you wait. We sound
Yeah.
like boomers. Have you heard of?
Yeah,
Have
okay,
you heard that?
boomer.
Yeah. See, Fraser
Yeah.
knows. Fraser's up
I'm not
to
a boomer
date.
though either.
I know.
I'm Generation X, and you're a millennial.
I'm
No,
I'm
you're
yeah, I'm a millennial. Well, they also have a
Yeah.
different one. Like it's like Generation Y or something. I don't
That's
know.
the new one. That's
Oh, is that
what
the
I think
new
my
one?
daughter is.
Okay.
My daughter's post millennial, right? My kids, because they're
Right.
born after 2000.
Yeah. So I'm on the cusp of it. I forget. There's someone else that told me this from my chat recently about what generation it is. So
Right.
I'm not 100% sure.
Okay, well, you know what? We'll just science it here.
Yes.
Jenna.
Because there's like another one. Oh, Generation Z is the millennial, or Generation Z is the new one, is what someone said. Devil said, and Devil,
Oh,
thank
really?
you. Yeah. Thank you for the resub, Devil. Yeah. Generation
Yeah,
Z.
yeah. All right. So they're the ones used as the mid to late 1990s as starting birth years.
Yes.
So no, my kids would be after that.
Yeah. So
What comes
they're Generation Z. So I would be Generation Y. But like,
No, we got Generation X, which is 65 to 80. So I'm 71, so I fall right in the middle of that. Millennials are 80, 90s, well, mid 80s, 86-ish to the 2000s.
yeah. So I'm
No,
85.
1981 to 1996 is a widely accepted definition.
See, that's such a broad,
You're a millennial,
right?
and then Generation Z is the new one.
Yeah, it's such a broad millennial. I feel is like a huge change because of the change in technology, right? From like say like even I was born in 1985, so from that point and experiencing the 90s in full,
I was just going into high school in 1985.
boomer.
Class of 89. Woo!
Yeah.
89.
See, I wish I could have been around at that time. That would have been a great time.
No way.
Really?
I would. Oh yeah. No way. I would put off. I want to see as much of the future as I can.
It's true. You
Yeah.
that is a very Fraser answer. That is, guys. That is such
Yeah.
a Fraser answer.
Yeah. People always ask me, like, do you go back in time or forward in time? Like, forward in time.
Ford. See, I'm like, no, I'll go a little bit back, but you have to be really careful about going back in time because,
Yeah.
but I don't know. I think, because we got to see the internet come into the house. And that's what I think really, really changes things. And like, I didn't have a cell phone growing up.
Yeah.
I
I didn't have a computer growing up.
You didn't?
No.
No?
No.
Not even like.
I got my, okay, so and I was like a nerd as a kid, right? So
Yeah.
I probably got my hands on a Macintosh in 86, right?
Okay.
87.
Uh-huh.
We used Macs in high school. Like we were doing journalism stuff in high school, 89. I had a PC. I had a Commodore 128 when
Okay.
I was 14, I think. So, I definitely got a chance to use computers quite a bit from, the late 80s.
Right. And if you guys didn't know,
And then I bought my own PC when I was like 18, 19, when I like 1990.
Yeah. Yeah. Fraser's also a computer science grad. So this is where Fraser and I both love space, and we ended up doing space stuff. And that's where we make fun of Dr. Pamela, is because she's doing the coding now.
And she's the astronomer.
And she's the astronomer.
Yeah, she's the best coder of all of us.
Yeah, I know. She's the one that does it the most. But I had a Commodore 64, Moda says in the chat, when I was 3. What?
There you go.
Asking my mom how to spell words to input commands. Oh, man.
I had my buddy had a Commodore 64, and then I bought the 128. So
nice.
Yeah, and I was like 14, I think. Yeah, it was super fun. It was a great computer back in the day.
Oh, yeah.
And it was kind of amazing. Like, we didn't have the internet, but we sure figured out ways to get our hands on video games, and I was sort of there when the first bulletin boards showed up, and we would dial in, and then you would chat with people, and you would be able to download programs that you could run on your computer. But the first time I played with the actual World Wide Web, it was right at the beginning, 1996. I remember it was like the winter of 96, like November, December, and you're browsing the World Wide Web, and you just go, this is it. I'd been on the internet before that. I was able to use Usenet and Gopher and these sort of other protocols before that. But yeah, once you used the World Wide Web, you knew instantly that this was going to change everything.
Oh, yeah.
There's no question in my mind.
Oh, yeah.
Right?
Immediately. Yeah.
Yeah. Yeah. And I mean, like, I'm still unsurprised at how the internet has taken off.
Oh,
because 24-year-old me saw it all. Just, like, I left the company that I was working for and joined another company that did internet development. I started Universe Today in 99, right?
Yeah.
Thinking that I was late to the party.
Yeah.
So,
see, I even have Universe Today. It's already populated. Just start typing in Universe, and it says, I'm going to go to Universe Today immediately. It knows where I'm.
Perfect.
I know. Guys, this is an amazing resource. You see me use it a lot with certain things.
Did you log in like I told you to?
Not yet. I haven't done Space Stream since you gave me that information.
Oh, okay, all right.
I tried to do one yesterday. My brain was too scattered. I had way too much.
All right.
I've been doing DMV stuff and all over, like, so my brain was just not even wanting to sit down and talk about space yesterday.
Like the Department of Motor Vehicles?
Yes.
Oh, okay.
Yeah.
All right.
I'm doing all kinds of stuff. So I was running around like crazy.
Updating your license.
Yes. License plates,
Again,
registration.
back to adulting.
Yes. Yeah. A lot of adulting yesterday. And it was something that happened in such a fast time period. So I was exhausted by the end of the day. But did you see the stuff that Phil Plait tweeted out today with I'm scared I'm going to, that solar telescope? I retweeted it.
The one in the brand new, and we posted a story about this as well. It's the highest resolution image ever taken of the sun.
Yeah. Oh, yeah, you did. It's right here. Boom. Yep.
And I'll take a crack at it too. Daniel Inouye?
I think it's I heard a few different pronunciations. Inouye. Yeah. Inouye, it might be. That's it. Inouye,
yeah,
maybe?
Inouye. It's in Haleakala. Yeah, it's a brand new telescope, and the picture is so great. And people are like, it looks like caramel corn.
It does. I'm going to pull this up, take our cams away for a second so everybody can see this in full. This is the sun, guys. By the way, this is the sun. This is what we orbit this bad boy. Isn't that crazy?
It's just and you can actually see video as well.
Yes.
Of it just sort of blobbing around.
Yeah, I saw.
And so you are seeing the convective cells on the sun, like little bubbles in a lava lamp that are floating to the surface.
Yeah.
Just a phenomenal picture.
Yeah, I think I even have the video here to show everybody too, because this is insane, guys. And I'll turn on your interview cam so you can be on all load.
Great.
No, but this is really cool. I was looking at this actually right before I called you. because they have this video that is unbelievable of just the sun here. Like, this is
Amazing.
insane. Look at this,
Yeah.
guys. Is that not
I wonder
freaky?
what the size is on, like, how big are each one of these little blob? Okay, so each one of these little blobbies is like the size of
Phil Plait said it in Twitter.
Texas.
Yeah.
So these are blobbies about 1,000 kilometers across.
Yeah. It's just, it's insane. And seeing it move. So I've actually seen this in a telescope before. Like when you see the movement like that. But not that high def. Not that high def. Not even close.
Yeah.
So
yeah, no, it's a phenomenal picture. What a see more. Like, I want to see the future. What will the future show us?
True.
Yeah.
And I can see that because this is really cool stuff. Like, the fact that we can see this is just unbelievable. I'm always shocked by stuff like that.
Yeah, and I mean, you're exactly right. You know, with a solar telescope with fairly high resolution, you can see this granulation on the surface of the sun, but not at this level of detail. It's just, again, unbelievable.
Does it look kind of delicious to anyone else?
yeah, fiery death delicious.
See, and I didn't even talk about this. I haven't even talked about this scope, and this is why we need Fraser around, because Fraser keeps me all up to date on all the space technology. Fraser knows all this stuff. If you guys want to talk about launches, things like that, that's Fraser. Starlink.
Yeah, well, hey, let's talk about Starlinks.
Yeah, so we can immediately. We could, if people want to hear about it.
If that's what, like, I am ready, we can cover whatever subjects that are going on right now. We can talk about the fact that Voyager 2 went offline and it came back.
Yep. I remember hearing about that. There's also, but one thing. Wait, no, there's one thing. James Webb Space Telescope. Did you read that?
Yeah, so apparently James Webb, what surprise, James Webb looks like it's going to be delayed again. Not so bad this time. So there is about a 12% chance that it's going to reach its targeted deadline of March 2021. And so now it looks like it's going to be going out to July 2021. So another 3 months.
And that was
sucks.
Because of why? Why?
Well, I mean, there's no one specific reason. So I did an interview with Paul Geithner on my YouTube channel about a month and a half ago, and we talked about it. And he was saying, yeah, the deadline is still March. Probably.
Maybe.
Like, maybe. I hope so. So, I mean, the way this worked is, like, when about 2 years ago, NASA did this really in-depth independent study of the state of James Webb. So they just crawled around Northrop Grumman, looking in every desk, checking every device, and really determining the state of the project itself. And NASA, and I've mentioned this, I think, in the past, that NASA is some of the best project managers on planet Earth.
Mm-hmm.
They've written some of the most comprehensive, most well thought out methods of project management. I highly recommend it. You can go and down, like, if you're in software development and you want to learn how some of the best in the world do project management, it's NASA.
Right.
And I based a lot of, back when I was running a software company, we actually based a lot of our methodologies on NASA. And so they went and just did this really in-depth review because they had been getting these constant updates from Northrop Grumman, and they kept asking for more money, and the dates kept getting pushed back. And NASA had done all their part. They'd done all of their experiments, were ready to go. All of the stuff that NASA had to do was complete, and they were waiting on Northrop Grumman to get all the other parts completed, and the price kept going up and up and up. And so they did this detailed audit, like I said, about 2 years ago, and revised the date and said, okay, based on what we've looked at, based on what still needs to be done, this is the time that we think it can actually be completed. And that was March 2021.
Mm-hmm.
And they put in a buffer of some number of months. I think it was like 90 days of extra buffer on top of that, of slack.
Right.
to meet that March 2021 deadline. And then as we were talking, most of that slack, when I was talking to Paul, like I said, about 6 weeks ago, a lot of that slack had gotten used up.
Right.
And so you could see that they were going to run out of slack time. And so now here we are a year away.
Right.
And it looks like the launch date is going to be 15 months away as
Yeah.
opposed to a year away, right?
Yeah.
And so it's understandable. I mean, if you've like seen people deliver a software project, these things slip, and they slip month after month after month. But as you get closer, the slips get smaller until finally it's ready to go, and away it goes. So
yeah, and the thing that I'm worried about is this. I mean, this origami swan, basically unfolds in space.
Yeah.
I mean, I just feel like the potential for so many things going wrong is so real too.
Yeah, there are hundreds of separate little actuators that need to go to make this thing unfold into its perfect full operation, with the sun shield, with the main mirror, with the secondary mirror, with all of the instruments, the solar panels. Everything's got to go perfectly, and there's no do-over. And so they need to make sure that it's right.
Yeah, and the pushback, I mean, guys, we weren't really surprised. I don't think anybody's really surprised at this point when, you talk about James Webb Space Telescope so much.
Yeah.
But why does it keep slipping? I mean, we just kind of went over that, but that they had some tests. They had some things that went wrong a few years back, I think, with, wasn't it like the sun shield?
There was a problem in unfurling sun shield, and they did a shake test, and some extra parts were found on the ground.
What were they, like washers, weren't they?
Yeah, like they shook it and things shook loose, and they didn't know where they came from.
They fell off.
yeah, exactly. So it took a little work to go back and figure out what was going on. So this is, I mean, there are so many pieces of new technology that have had to be developed to figure this telescope out, to make it do its job. And it's funny to me, like, obviously, like, there's a lot of people that are just like, this is ridiculous. It's never going to happen. But at this point, it is going to happen. Like, it's only a year and a bit away now. Like, it's pretty much done. It just needs to be packed up. A lot of the deadlines, a lot of the work that needs to be done is taking it down to the launch center down in South America. So it's got to be shipped down by boat. It's got to go through the Panama Canal, because it's in California right now. It's got to go to French Guiana, which is on the eastern side of South America, and then it's got to be integrated with the rocket. It's got to be all of its umbilicals have to be attached, and then it has to be tested again, make sure everything's good, and then it has to be launched. So, there's going to be a point where it leaves the boat, when it gets on its boat and leaves for the launch facility, and you can anticipate that it's going to, at this point now, it's a done deal. Like, the moment it leaves Northrop Grumman, it has effectively launched.
Right. And Joe actually has a good question. So why do they need a deadline date?
Well, I mean, because if you don't give people a deadline, then people will just wander around randomly bumping into things until everybody runs out of money. And if you can never run out of money, then nothing ever gets done. So there's no specific deadline in terms of, like, there's no, like, with Mars 2020, for example, they've got to get Mars 2020 on the launch vehicle and ready to launch when the launch window opens up to go to Mars. And if they don't make it, then they have to wait 2 years to take another crack at going to Mars. So it's a big problem. In fact, the European ExoMars mission is having a lot of problems with their parachute. And so if they can't get this solved, that spacecraft is not going to Mars in 2020. It's going to have to wait till 2022. So, but with James Webb, there is no specific deadline. There's no, no event in the universe, but there is a whole bunch of other spacecraft that are depending on James Webb. There's a lot of programs. There's a lot of engineers that are expected to move to other projects. There's budgets that need to be cleared up. So they, and when you're doing project management, right? You ask the engineer, you ask the developer, you're like, how long do you need to do this thing? And they say, I need 3 months. And you're like, great, 3 months it is. I will put 3 months into my calendar, and we'll tell people when they keep asking me when, then it's going to be done in 3 months. And I'm going to budget that amount of money, and I'll know how much the whole thing's going to cost. And if you tell me if we come back and it takes 6 months, then the price is double. And if I'd known that in the beginning, maybe I would have said no. Right?
Right. Now
I'll bet you if someone had said, oh yeah, no, it's going to cost $10 billion for James Webb, not the $1.5 billion that we originally anticipated. It's possible that people would have said, no.
Yeah,
no, we don't want that.
No,
yeah.
that's taking a lot of resources.
That's too much money.
It's a lot of money.
Yeah. We can spend that money on other things. So and then you're into the sunk cost fallacy, which every developer is deeply aware of. This time when you're way over budget, way too long, and you're still having to develop. And every day you have to ask yourself, do we just abandon this project, right? Should Fallout 76 just been thrown in the garbage?
Yes.
Or should they have they just kept developing it?
Someone asked, wait, Europe has plans to land something on Mars?
Yes. Yeah. And China does too. So 2020 is going to be a really busy trip to Mars. You've got NASA's Mars 2020 rover, which we don't know what it's going to be called yet. Perseverance. I forget some of the other names.
Like Endurance.
Clarity. Purity. I don't know.
Purity.
Pestilence.
Patience.
Patience. Yeah.
Hey, Dustin. Dustin's in here.
And then you've got the Europeans. They're sending their ExoMars mission, which is going to consist of an orbiter and a lander. The lander's called the Rosalind Franklin. And then the Chinese are sending their own rover to Mars in this window as well. So, as a prelude to get ready for this, China is planning a Mars sample return mission. So this is step 1 of their Mars sample return mission.
Yeah, and I think that's a good idea. I like that idea.
Europeans and NASA are also planning to do a Mars sample return mission as well.
How come we don't hear about that one too much?
I don't know. Maybe you're too busy not thinking about it. Like
streaming, too busy streaming.
Yeah. Have you watched my episode on the Mars sample return mission?
No.
Video? Okay.
No.
Well,
Okay. All right. I'm picking up what you're dropping. Dustin's in here.
That I've done a whole video. Hey, Dustin.
He says,
thanks for letting us use your telescope, Dustin. We had a great time.
Yeah, it was awesome, Dustin. We got so many great pictures, and they're in the Discord. Even though I know we're never gonna make Dustin try to figure out Discord again. Actually, probably will at some point, but at some point.
It is 29 episodes back.
Oh my God.
Is the Mars sample return mission video.
So what month was that?
Oh, I don't know. Do you want me to just give you a link in the Discord? Here.
I mean, I could look it up too and stop being lazy.
See, but it was definitely before. Clearly, see, this is for this very reason, at least so that you can watch my videos and share them with your audience, of course.
I love doing that. So we do that all the time. Yeah, that's from a while ago. Mm-hmm. Yep. Mm-hmm. Wait, this might be when I realized my house was falling apart.
Maybe.
Yes. Yeah. Yes, that's about right. That's about right. Good. Yeah, so that's why. But I have it up now, so we will watch that because I didn't know that was a thing. I knew that there was talk about it. I didn't know where that was, and I know about China and Europe, but I don't really talk about Mars too much because I feel like you could just talk about Mars all the time with all the stuff that we're doing with it.
And should.
Listen, Fraser. That's another Fraser answer. And should.
Yeah, you could and should.
Yes.
Yeah, every second that you're playing some video game or watching some history documentary, you could be talking about Mars.
Oh man. Oh
Yeah, just
man.
saying. Yeah,
Yeah. Will we send missions to the
shots fired.
moons to the moons of other planets?
Will we send what?
Missions to the moons of other
We
planets, which we have the ready are.
have?
We have.
Yeah.
Oh yeah, no. So we've had we have Clipper coming up with
Yeah,
Europa.
the Europa Clipper is going to be going to Europa. ESA's JUICE mission is going to be going to the moons, the other moons of Jupiter. It's going to do Europa, Callisto, and then it's going to go into orbit around Ganymede. There is the Titan Dragonfly mission that's going to go to Saturn's moon Titan. That's all that's planned for the future. And then, of course, in the past, you had the Huygens mission on Cassini. You had and then the Galileo spacecraft took images of all of the Galilean moons. And then, of course, there's the moon, which has all kinds of things happening over there.
Yeah, New Horizons, I'd say, counts too, because it did see Sharon.
It did see Sharon, yeah. Yeah, that counts.
That counts. I've forgotten if Europa was happening, if I mixed it up with Space Odyssey. Yeah, no, Europa's definitely a thing. We're very interested in Europa.
Clipper.
Yeah. And Enceladus will also be interesting. I don't know. Do they have something with Enceladus?
There's no plans right now to send anything back to Enceladus.
Man.
Yeah, and I mean, partly it's like it was just a gigantic surprise at how interesting Enceladus is. Right? Surprise, there could be life here, and no one had another mission planned to go to Enceladus.
Yeah.
You know, they had plans to go to Europa. Like literally the moment they were like, wait a minute, this place might be filled with water. Let's send a mission. And so, but now we know how exciting Enceladus is. So we've got to go back. Go back to all the places.
Yeah. No plans to go to Venus, someone asks.
Well, so there is a mission at Venus right now. There's a Japanese mission. And then there's no additional plans. I mean, the cool thing about Venus is that it's this stopping point for all of these missions that want to do flybys. So the Parker Solar Probe, the Solar Orbiter mission that's going to be launching in just over a week is going to use many flybys of Venus to essentially tilt its orbit so that it's going as much above the sun as possible. And you've got the European Lucy mission is going to do a bunch of flybys of Venus. So each one of these does some observations of Venus as they fly by, but Venus is obscured by all of the thick clouds. So you need very specialized instruments to actually see what's going on down beneath Venus. Of course, I did 2 episodes, one on plans to send rovers down to the surface of Venus, and then another to study the atmosphere with balloons and Stingray aircraft and such.
Yeah, I think
Are you gonna need links for those?
I have your thing up. We're gonna watch a bunch of this after this because this week I don't have anything like to lecture on or whatever. So
okay, great.
Yeah, but and yeah, guys, again, like if you do the Fraser command, you have all of his stuff there too, because he has so many good resources that I mean, a lot of people on here that come on here usually have pretty well developed YouTube channels with really good space information, and yeah, with Venus. So you could even propose, and I obviously will have to watch that, but a rover landing. How I mean, you'd have to have so you'd have to get through that insane pressure, atmospheric pressure of Venus. And then it rains sulfuric acid.
Yeah, that's a
not
bonus.
good. You know,
No.
I mean, for equipment.
There's the pressure, the temperature. Don't forget the temperature.
Oh yeah, 900 degrees
to melt zinc.
Yeah.
So yeah.
Because we have landed. I think was it the Russians? They landed They had a lander.
So the Russians have landed. The Soviet Union landed a series of missions on the surface of Venus with the Venera program.
Right.
And they did a great job. I mean, I love this idea because the Soviets figured out how tough they had to build their spacecraft by essentially suiciding them into Venus one after the other. And so we think this is how dense the atmosphere is. We think this is what the temperatures are, but they didn't know. So they sent a spacecraft, it went down, and it died. And they're like, okay, tougher than that, hotter than that. So they sent another one that was built a little tougher, and it died. And so but they were getting the temperatures, they were figuring out the pressures. And so then they completely overbuilt their spacecraft, and they finally were able to make it down to the surface. Because with Mars, you've got that really thin atmosphere, and so spacecraft, they bounce off the atmosphere, or they don't get slowed down enough and they smash onto the surface. But with Venus, it's very easy. You just open up a parachute, and your spacecraft is going to make it gently down to the surface of Venus. It just will be dead on arrival. So they just did a great job of figuring that out. And Hoot Marut is talking about the lens cap failures.
Yeah.
As I go into this quite a bit on my video about how they got the spacecraft down to the surface, but its lens cap failed.
Didn't that happen like twice?
More, yeah. I think 3 times they had lens cap failures. But I mean, it's not like a lens cap like you just pull the lens cap off your camera and take a picture. I mean, again, try taking the lens cap off of your camera while it's in the middle of your oven, and your oven is at 500 degrees. See how that works for you. 500 degrees Celsius, right?
Right.
Give it a shot. Like, one, your hand will burn, right? So obviously, the rover's little hands burned. Your lens cap will burn. Your camera will burn. And your whole spacecraft will burn.
Everything will burn.
Everything will, yeah. Everything just lights on fire. So they had to use a piece of quartz crystal that they had to shoot through, like a clear piece of rock that they used as lens caps. And so it's sort of really interesting technology.
Yeah.
Yeah. Yeah. And it's just like, I just love this idea of them. And I would love to just talk to some of the people behind the program who worked on it, and they just wouldn't give up. They're just like, we're going to put a spacecraft down on the surface of Venus and whatever it takes. And in the end, they took some pictures of the surface of Venus, and we have them. Mm-hmm. We can look at that and go, that's Venus.
Yeah. And someone asked earlier about Titan. So we talked about the Dragonfly, and that's going to be like a helicopter.
Yeah. A nuclear powered drone. Quadcopter.
Yeah. And they asked, has there been any news for the project to land a submarine on Titan?
No updates. So this was a proposal a couple of years ago that you could actually go and send a submarine to Titan, and it would be able to explore these methane-filled lakes and seas that are on Titan. And it was a great idea. Send a submarine, and it would just be able to bob up and down and go down to the bottom of these seas and look around and examine the chemicals and pop up to the surface. But in the end, they decided, or in the short term, they decided that the goal is, let's send an aircraft, because you can just cover more ground with a helicopter, right? Mm-hmm. Get around, see what everything looks like, and then if they find a lot of really interesting features and they want to come back and explore in more detail, then a future thing will do it. And unfortunately, where they're sending the lakes are up in the poles, while they're going to send a helicopter to the middle, to the equator. So unfortunately, the helicopter won't be able to actually go and see these lakes. It's just going to be too far.
Yeah, and it has pretty cool topography. It has mountains and such.
Has mountains, has sand. I mean, the great part about it is that everything is weird. So everything is shifted one state. So the mountains are made of ice. The sand is made of ice. The oceans are made of liquid methane.
Right.
And then the whole thing is covered over top of what's probably some kind of liquid water ocean underneath. So it's like an ocean within an ocean.
Right.
So Titan is absolutely a fascinating place, and we've got to go back to, but just like there's so many places that we've got to go back. So
yeah. We haven't gone back to Uranus or Neptune.
No, and both NASA and the European Space Agency have some pretty serious plans to go back to both of those worlds. You're seeing it start to make the rounds again as part of the 2020 decadal survey for NASA, and the Europeans have their upcoming cosmic, I forget what they call it, cosmic vision series, and they're considering going to Neptune and Uranus as well.
Huh.
So places we got to go back.
Yeah, we've been talking about that for years now. You and I.
Yeah, exactly. Finally, people will listen to it.
Finally.
They thought we were crazy.
I know.
We're not.
And we just got rated. Thanks, Horizon, for that. So is Venus greater than 100 degrees short of having glowing metal?
Well, it depends on the metal. What is it? Zinc, lead, cadmium. There's a bunch of metals that all melt.
Yeah, it's pretty insane, guys.
Yeah. I just pick a new metal that melts on the surface of Venus.
Yeah.
It's hot enough to melt zinc.
It's pretty hot, guys. Like that's
pretty hot.
I mean, as much as we've talked about this before. Like, could we live on Venus? And you had a video about living in the clouds. We did watch that.
Yeah.
Everybody's saying nice picture of the caramel popcorn. Yeah, guys, this is the sun. That's the sun.
Yeah, that's caramel popcorn of fire.
Plasma. I guess our zinc pennies won't survive the trip. Why is it so hot? So it has a runaway greenhouse effect.
Yeah.
So
sucks to be Venus.
Really sucks. All that heat, it just gets trapped. It has no way to escape.
Yeah.
So it heats up that surface, and yeah. But is there any other cool things like with space? Because no one's asking questions right now.
I know. Weird. Any
I know.
other cool things with space? Hold on. Let me see what's interesting to me. What did I report on fairly recently? Cheops just opened up its eyes.
Yep, and
so
that's
was the European Space Agency's planet characterizing mission, Cheops.
Mm-hmm.
That's pretty cool. So this is a mission that's going to study known planets. So it's not going to discover any new ones, but it's going to study all the known ones and help characterize them, figure out how big they are, what their orbital period is, maybe chemicals that are in their atmospheres. So it's a pretty cool next step. And with, at this point, I forget the number, 4,500-ish confirmed exoplanets with 10,000 plus unconfirmed, there's a lot of candidates out there to go and study.
Yeah, and Cheops, wasn't it taking over for something else? Or am I remembering this wrong?
No, not that I know of. I mean, Cheops is sort of like a good partner to TESS. So TESS finds them and Cheops characterizes them, studies them.
Right. No, maybe I'm thinking of another one. I'm thinking of one starting with a B. It's a mission starting with a B. I'm not...
Bepi Colombo?
Yes.
That's a mission to Mercury.
Right.
From the European Space Agency.
That's totally different. Why am I thinking about that? I have no idea. I have no idea.
Because all these missions just sort of blend in your mind.
They really do. This is why we have Fraser on here, guys, because I can't keep up with all this and stream and have a life.
Yeah, exactly.
That's why Fraser has the whole universe today, because he can read this.
Stay on top of all of it. What else is interesting? We got the 4th launch of Starlink.
Mm-hmm. I'm so we've now got excited.
240. You're so excited. I know. I feel bad about pulling when we see the star trails going through our pictures, but it is absolutely stuck in my head now. I call them Starlinks. So we saw all the satellite trails. Like people are always like, what's it going to be like? I'm like, join us on a star party.
Yeah.
You'll see how this plays out.
Yeah.
As we have to go, that's a great picture, except it's got a bunch of lines through it. So that's in the garbage.
Yep. Wait, there are
imagine
questions
that was your science.
now. I know. There are questions coming in now, but I don't know. Maybe someone. Well, let's start with the question, then we could go back to Starlink as our default.
Yeah. Or Betelgeuse. We haven't talked about Betelgeuse yet.
Yeah. Hypothesis on how far we are from intergalactic travel, Fraser.
Forever. Um, so again, I mean, define we, define far, and intergalactic travel. So traveling from here to like Andromeda, that's hard.
Yeah,
I mean,
that's a long ways away.
That's a long way. If going to the nearest star is pretty much beyond our current capabilities, actually trying to go to the nearest galaxy is times 1,000,000.
Yeah.
Or so.
Because
so
light,
1,000,000 times harder than a thing that is 1,000,000 times harder than we can do.
Yeah.
1,000,000, what's that? 1,000,000,000,000? Trillion times harder than something we know how to do, which is a lot.
Yeah, Andromeda is like 2.5 million light years away. So,
That's
and
right,
our
yeah.
nearest star is 4 light years, and 4 light years is daunting.
Is beyond daunting.
Yeah.
Yeah. Yeah, you could send a mission, and 1,000 years later, future generations would be there when the mission arrived.
Yeah.
To the closest star.
So. I saw an argument between. Wait, can you say, because is it Kyrgyzstan?
Kyrgyzstan, but that's bad. Kyrgyzstan. But that's wrong.
I know. I always just skip over it.
Yeah. Between Kyrgyzstan and Cody's lab, that's awesome.
And how far
what a great group of people.
Interesting, Paul.
I love Kyrgyzstan and Cody's lab. So if you're looking for 2 great channels, both of those are totally worth following.
Terraforming an asteroid is going to suck. I don't know how feasible that would be to terraform an asteroid. It's really going to be dependent on how big the asteroid is and what it's made of. And
yeah, terraforming an asteroid is kind of like pouring water on a basketball.
That's exactly what I was thinking. Yes.
Yeah, you pour water on a basketball and the water just pours off again onto the floor, and you're like, how come there's not an ocean on my basketball? Because there's just not enough gravity.
Right. And then if you start wanting to have like a bigger size asteroid, you might have a moon at that point, right? So
sure. Yeah. So I mean, you could build a nice atmosphere around the moon, our moon, the moon, but you would need to do it again 10,000 years from now.
Yeah. Anti-gravity boots. Okay, so I think a lot of people have watched The Expanse. I'm just feeling very Expanse-esque questions right now.
Yeah, no kidding. Anti-gravity boots that's not that complicated. I mean, what they were doing in The Expanse is relatively straightforward. I mean, you have a really powerful electromagnet that as you take a step on your metal decking with your magnetic boots, you are stuck to the ground. And there's no, it's not like you're being pulled away from the ground. So it just needs to stick,
right,
so that you can move forward. So we could build that technology today. The part of The Expanse that we can't build today is the Epstein drive. The poorly named Epstein drive.
It's a terrible name.
Come up with a whole new name for this drive. Yes.
I always forget that.
Yeah.
I read an article this morning about this picture of the sun, but on what satellite the telescope has been attached to. Is it orbiting Earth? The one that we were working on, the Inui.
No, that's a ground-based telescope on Haleakala in Hawaii.
In Maui.
Yeah, in Maui. So this is the benefit of ground-based telescopes, right? Is you can build a telescope for a reasonably inexpensive price, and you can take the highest resolution picture ever taken of the sun. Yeah, if you took this fairly beefy telescope and sent it to space, it would take an even better picture. But, have you ever tried sending a building to space? It's tough. It's complicated. It's expensive.
Will we ever be able to land within Jupiter, and how should we examine Jupiter without damaging instruments? Is it possible?
Within Jupiter?
Well, okay, so first, we already have the Juno mission.
We already did land within Jupiter with the Galileo spacecraft.
Galileo, yeah.
Yeah, Galileo landed within Jupiter, and by that I mean crashed into Jupiter and burned up.
Yeah, it got destroyed.
Yeah.
Same thing we did with Cassini.
Same thing with Cassini into Saturn. So and like people always have this concept in their mind, right? It's a gas giant. And so it's made of hydrogen and helium. So it must just be this fluffy puff that's out there in space. And you just fly your spaceship right at Jupiter, and you just fly through like a cloud, and you come out the other side, with this little puff of smoke as you make it through Jupiter. But it's not that, right? It is an enormous amount of mass. The solar system is 99% the sun and 1% Jupiter, and the planets are like 95% Jupiter and everyone else. And so Jupiter has an enormous amount of mass. I forget, some hundreds of thousands of times the mass of the Earth, and held under this incredible pressure. And so, yeah, the very highest layer, where it is like twice Earth gravity. If you could like stand on the clouds, which you can't because you can't stand on clouds, you would be experiencing about twice the gravity as you experience on Earth. But as soon as you go down a couple of 100 kilometers, the density starts to increase, and very quickly it's as dense as water, and then below that it's as dense as rock, and you're still only a little bit into Jupiter. And this is just hydrogen, as dense as rock, dense as metal. And when you're in the core of Jupiter, it is hydrogen at a density that you just can't even wrap your head around. So there's no landing on, in, near Jupiter. You want to stay away from Jupiter.
Yeah, I always say it can make hydrogen its metallic form. It can make metallic.
Yeah, it crushes hydrogen so efficiently, right, into a form that scientists still struggle to be able to do, and it just does that because it's fat.
It's a big boy. And someone said, how is it gas? How is it a gas if it's so massive? So it just has a lot of gas. A lot.
It's made of a thing that if it was here in your atmosphere, it would be a gas, right? That's all.
It has a lot of the same chemical makeup as the sun.
It's almost precisely the same chemical makeup as the sun.
Yeah, it's mostly this hydrogen, and it has some helium, and so it's not a gas. No, it's absolutely a gas.
Yeah, it's made of. Well, I mean, what is a gas, right? Like a gas. I mean, so they call them gas giants because they're made of hydrogen and helium, but they are arranged in structures inside them at such high pressures and temperatures. So like, what do you call hydrogen that is arranged in this high density lattice, like that is as dense as metal and acts like metal, but it's still hydrogen. It's just hydrogen. So it's like the difference between, I don't know, a diamond and a tree.
Right.
They're both made of carbon,
but one has more pressure.
One has more pressure, etc.
Yeah.
So imagine inside Jupiter is more diamond-like than gas-like.
Yeah. Someone says, someone says, so it's cold. Yeah. So it's cold.
No, it's hot.
Well, it gets hot as you get further in.
Yeah. So you go, like, if you get down again within just a couple of 100 kilometers of Jupiter, the temperature starts to go up and up and up. And by the time you're at the center of Jupiter, the temperature is like 25,000 degrees Celsius. So it's hot.
Yep.
Wait, maybe that's the temperature of the interior of the Earth. Hold on. Maybe
I know Jupiter.
100,000?
I think Jupiter, because it is cold for a bit, but then not too long. Because once you get in there, more and more.
Yeah, just below the cloud tops, it starts to heat up.
Starts to heat up significantly.
No, I'm right. Yeah, 25,000 degrees Celsius. So the core of Jupiter is 25,000 degrees Celsius.
Yeah. How would anything withstand that gravity pressure? It doesn't.
Yeah,
like, I mean, we wouldn't.
Yeah. Let me see what the density is. 12,000 kilograms per cubic meter.
Yeah.
So you have a meter, and it would weigh, I don't know, 12,000 kilograms.
Yeah.
25 tons of weight for a kilogram.
Yep. That's pretty substantial.
That's substantial. That's, would you like to fly your spaceship through something that has a density of 12,000 kilograms per cubic meter?
Yeah.
No.
I wouldn't. I'm reading that. So other people are saying, Jupiter also rotates pretty quick. Like
Yes.
a Jovian day is what, like 10 hours
Yeah,
approximately?
it's really quick. Yeah, 9 hours and some number of minutes.
Like 50 minutes or something like that.
Yeah.
And yeah, we use it a lot for gravitational assists with probes and stuff.
Yeah.
Because again, it's massive.
Sire Awe asks if will Jupiter turn into a star, a la Space Odyssey? Only if you crash another 77 Jupiters into it.
Yeah.
So yes, with the provision that you need to have 77 more Jupiters lined up, and you smash them one after the other into your one Jupiter, and then you end up with enough mass for Jupiter to be the minimum star that can actually undergo fusion.
Yeah. That red dwarf star is like 70 to 80 times. Yeah, it's mass, its own mass. It's pretty flat Jupiter, Dustin. So you're saying that there's a chance. Yeah.
So you're saying there's a chance. I'm saying there's just a possibility. What you didn't see in 2001 when the camera turned away was the aliens merging together another 77 Jupiters together.
Yeah. And I think for it to be that brown dwarf, which is a different kind of fusion. It's like a deuterium.
That's right. Yeah.
Kind. I think it's like 13 to 20 times. I forget exactly.
So less. So you don't need to. So if you're okay with, like, deuterium fusion,
right?
And I mean, who is, right? I mean, it's not really a star.
Yeah.
Then you only need another, say, half dozen, dozen Jupiters.
Yeah. Yeah. Like, could you jumpstart it with a concussive shock of some sort? I don't know what.
You could jumpstart it if that concussive shock is 77 more Jupiters.
Yeah, you need to add more mass. Guys, this is a problem of mass.
Yeah.
This is not like Sunshine, which is a great movie for sci-fi, but you can't send something to the sun, like launch Earth at it or reignite the sun.
Yeah. I love this question there. Sergeant Klatt says, "Does Fraser stream?" It's such a cultural divide here.
It is.
It's funny.
He has his own YouTube, and guys, if you do the Fraser,
I'm a YouTuber, not a Twitcher. Mm-hmm. I think that's what you call it. Do you guys have Twitchers, Twitchies, Twitchsters?
I don't know. Oh gosh, if they call us Twitchers, that'd be terrible.
Yeah, Twitchsters.
I'd cancel my stream.
Tweakers?
No, get out of here. Yeah, I think that's terrible.
Twerkers?
I think we just say streamers.
Streamers, okay. Well, but then I stream.
Yeah, because he does go live on his channel sometimes. There's been events that he's gone live
every Monday at 5 p.m. Pacific.
Oh,
I
that's
do my
right.
Open space live stream, 1 hour with me, sometimes a guest, or sometimes I'm just answering questions. It's kind of like this.
It's kind of like this, and that's where he had that wonderful copy pasta, the Q&A, right?
Yes. Well, no, the QA is my QA show. That's the other thing I do. Those are on Thursdays. I just released a new QA. That's where I take the questions and I record an answer to kind of ruminate. But the QAs are just live.
Okay, so the QAs are on Thursdays. This one's on Monday, but then he also has the weekly space hangout, and that's on Wednesdays. That's on Wednesdays.
Yeah. Yes, I should simulcast on both Twitch and YouTube. Yes, I'll figure that out technologically. I know, like, for me, I'm a free agent. I have no allegiance to Twitch nor YouTube, so I can Twitch simultaneously to both.
Mm-hmm. And he's already got the YouTube stuff figured out. So,
right.
That's a challenge.
Is YouTube the harder one to figure out?
Oh yeah.
Oh, okay. All right.
Well, I mean, I guess they have their own problems, but I think YouTube's a more challenging algorithm.
Wait until Mixer comes calling, says Joe. Yeah. Me and Ninja are gonna have that. Are gonna have those exclusive deals on Mixer.
Just sub to him on YouTube. Yeah, he has a bunch of great stuff on there, and also he has Astronomy Cast with Dr. Pamela. So they both host that. That's on Fridays. Like, Fraser's pretty. That's why usually Thursdays we would have him on here.
Yeah. We actually started streaming in 2012, 2011. We started. So we used to do Astronomy Cast as a, like, Pamela and I would talk on Skype and record the show, and no one would hear the live, us actually doing the recording. And then we figured out how to actually get the how to do the show live on Google Plus at the time. And that worked out really well. And so we haven't turned back. So we've done every one of our shows for the last 8 years.
Yep.
9 years live.
Which is actually really cool. And, I didn't know about that until way later.
Yeah. Well, because we edit out the podcast part of the larger show. And we do all the stuff that we do, all the Q&A with the fans that are watching.
Yeah. And Astronomy Cast is like one of the reasons that I'm even a science communicator now. I mean, but it is. And so that's like, guys, I mean, it's a huge resource for astronomy. I can't even just any information, all of their stuff, everybody that I've listed and all of Fraser's stuff. But yeah, I used to listen to Astronomy Cast and you know this, but a lot of my chat might not, but I listened to it like day and night. That's all I did. And it was such a great resource to pull from and start my own thing. And having other people kind of already doing it. I didn't know that was even a thing. I didn't know science communication was really a thing at all.
Yeah, it's such a weird thing now how fractured just all media is.
Yeah.
Right? And so people they'll find their way to the content. And I can't believe I didn't know. Well, I don't know what else more I can do, right?
Right.
I pretty much do some kind of live stream, put out a show every day. I do newsletter. I got a website, email, everything.
Mm-hmm. Yeah.
I'm in your dreams.
Yeah.
But that's it.
Yeah. Well, I don't want to take up too much more of your time. I know it's been about an hour.
Oh, sure. Okay.
Unless you want to take 2 more questions.
Yeah, let's do it. I got time.
Okay. I just don't want to take up your
we got to make up for lost time here, right?
True.
It's been
True.
6 months. So
yeah.
So I think that at least I owe you at least 2 more questions for the missing time.
Well, I'll have the chat.
All of those Thursdays, I didn't even have to give up an hour of my day. It's been great.
I know. No, we'll just the Betelgeuse one.
Sure. Yeah.
Because
talk about Betelgeuse.
Yeah. But how about we just keep calling it different names to just start confusing people? Yeah. Betelgeuse.
Betelgeuse. Somebody sent me a pronunciation of the Arabic way of saying it.
Oh, was it fancy?
Yes. Yeah. So I should learn that and then say it I'll force myself to say it. I mean, like the one, you do this too, which is great. So we say Pluto and Charon. Right?
And there's Karen.
And people say Karen or Charon or Charon or Sharon or whatever, right?
Right.
And so Charon is the way that Alan Stern from New Horizons pronounces it. And that's good enough for me.
Yeah.
Right?
Yeah.
If the director of the mission going to Pluto calls it Charon, then the battle is over.
Yeah, and somewhere I read, or actually I think I watched something on it where the guy that named it, he named it after his wife.
Yeah.
So I was like, okay, Sharon, I'll go with that. But with Betelgeuse, Betelgeuse.
Yep.
I'm gonna say I take all. I think everything is good.
Doesn't matter. Mm-mm. And just like with Uranus. Mm-hmm. it is pronounced in whatever way makes it most hilarious in the moment.
Right. Yes. Like when we were doing the star party.
Yeah. Like, hey, everybody, do we want to look at Uranus? Mm-hmm. Right. So, and so if you're trying to try to minimize the giggles, then you just say Uranus. But if you want to sound really pompous, then you say Uranus, which is apparently the closer to the Greek method.
Wow.
So, yeah.
I've never heard that.
Yeah, if you talk to a person from Greece and say, how do you pronounce this word? They will say it's Uranus.
Oh.
Yeah.
That's interesting.
Yeah.
Okay, so but it's dimming the star, and it's even dimming a little bit more and more.
Yeah.
I mean, it's pretty dim.
Yeah. it's at this point, like, it's just crazy now. Like, you go outside, you look at Orion, and if you're at all familiar with the constellation, the star is so much dimmer than it used to be. It's now down. Last time we covered it about a week ago, it was down to 1.5 magnitude, which is kind of now just like a regular star,
Right.
Yeah. Not one of the 10 brightest stars in the sky, just like a regular star. And the thinking is that this is a normal variation. It's gonna come back to more brightness again shortly, and that's what you'll expect. There's no reason to believe that it's going to explode anytime soon, and yet there's a hope it could blow up.
Yeah, Joe says, but why? So it's a variable star, which means
there's a bunch of different mechanisms that are all going on at the same time, and the biggest one that's causing the variation is that it is a variable star. And so it has this standard cycle where it produces a bunch of energy in the core, it puffs out, it gets dimmer, weirdly, and then the outer layers cool down, and then it starts to compress back down, it heats itself up, gets brighter, and then expands back out again. But it's also blasting off tons and tons of its outer layers of gas and dust, which from our perspective could be obscuring the view to the star. And then it also has these big convective cells. So you're seeing the convective cells on your screen right now, right? The ones of the sun, and they are the size of Texas, Governor. Mr. President, is that how that goes? It's the size of Texas. Anyway.
I don't know. I can't back you up on this one. You're on your own.
That's an Armageddon reference.
Well, that's why I don't know it.
So Betelgeuse, the convective cells on it are 60% the size of the star.
Yeah.
Right?
So it looks like we always call it a certain kind of candy. What are those called? Those Roche for
Okay, sure. I'm thinking like a blackberry,
Yeah, I don't
blobby seeds on it, right?
Ferrero Rocher.
Ferrero Rocher, yeah. But imagine that, the nodules on the Ferrero Rocher are 60% the size of the entire star.
Rocher. Okay, sorry.
Yeah.
Okay, so it's going to be like the Roche limit. See, that's how I was reading it. So it's Rocher. Yeah. Sorry. Okay.
Yeah, Rocher.
But they're much bigger. So, like, as you said, those dents in that foil from what I'm referring to, they're just significantly larger.
Like 60% the size of the star.
Right.
So just imagine those blobbies, right? Not 60% the size of the sun, 60% the size of the entire of Betelgeuse. So it's just this, I don't know, it just looks like someone took like a bunch of blobs and stuck it together, and that's the star. Hard to wrap your head around. So those, as they are, these convection cells are rising and falling and changing in temperature, changes what we see on the star as well. So it's a wacky place.
Yeah.
And someone is saying in the chat that it looks like it might have gotten a little brighter again. So
yeah, and I think that was kind of the concern. Like, it would be more if it remained as dim or kept getting dimmer and stayed that way for a while, that'd be more signs of it potentially.
Yeah, if it continued to dim.
Yeah.
There'd be a certain point where we are well out of the normal range.
Right.
But
right.
We're not there yet.
Yeah. And so again, like, if it just does this stays relatively dim for a little bit, that's not really a big deal.
Yeah.
It's when you see longer periods.
And so those convection cells, like the ones you're seeing on the sun right now, right? Like the sun has 3 layers, right? It's like an ogre. And so in the center is the core, the central core, which has where the pressure and the temperature is so much that it causes fusion of hydrogen into helium. But then around the core, there's this layer, where it's called the radiative zone. And that's the point where where it doesn't do fusion, and then the only way that the energy that's generated in the core can actually get through this is by jumping from atom to atom. So an atom will absorb a gamma ray and then send it back out again right away. And so the photons do this random walk all through the radiative zone. And then at a certain point, you get to the outer layer, which is called the convective zone. And so what you've got this soup of hydrogen, where hydrogen gets up to the surface of the star, releases all of its heat, and then falls down towards the top of the radiative zone, picks up more heat, and then floats back up to the top and releases that heat again. And so when we're looking at this picture, we're seeing the top of these convective cells that are releasing this energy. And with Betelgeuse, it just goes to an absurd level, right? You just got these enormous convective cells that are releasing this heat like big, I don't know, popping blobs. So
yeah,
it's incredible.
And someone asked, so if Betelgeuse did go supernova, we would see it in the night and daytime sky.
If it exploded 600 years ago, we still wouldn't know. No, it's true, because it's 640 light years away.
Yeah.
So it would take an extra 40 years. But do you have a way of just explaining this? I'd love to hear your pitch on stop. Here's why we don't talk about things in the past.
So wait, just talking about how, like, what we were just talking about there?
So I'm going to say, like you say, Betelgeuse could explode anytime now. And then in the chat, someone goes, "Hey, dummy, don't you know that in fact we're seeing it as it looked 640 years ago? So if it did explode, we won't know about it until now."
Yeah,
You must get that.
Oh yeah, no, I usually.
Yeah, how do you shut that down? How do you deal with that?
With saying, well, I always say it's 643 light years away, or between 700, and that means that it takes 643 or 700 years, depending on whichever one you want to take, in between that, for that light to send a photon our way and for us to see it with our eyeball. Yeah. So when we look at the night sky, we're essentially looking back in time. So if we see a star that's 4 light years away or 7 light years away, you're looking 7 years in the past.
But why? But the point is that astronomers say things are happening now. Right. So when we look at the stars look nice tonight. That galaxy, we're watching a galaxy collide. This many billion light years away, right? Right. And so the point, all the point is, I'm amazed you don't get. Maybe you just don't get this a lot. Maybe we just get this on YouTube. Maybe they're meaner on YouTube, and the people on Twitch are super nice. I've got to believe that's the case. No. Right, but and so people are imagining that there was some kind of concept of an objective now, right? That there is just now, and so if you look at Andromeda, you're seeing as it looked 2.5 million years ago. Therefore, Andromeda is 2.5 million years old. Right. And so people are like, hey, dummy, you can't say that Betelgeuse is going to explode today if we're seeing the light really happened 640 years ago. Obviously. Right?
Yeah, obviously. I don't get that a lot. No, because usually people want the explanation of how that works.
Okay. So no. I get the know-it-alls who already understand that light moves at the speed of light. Right. And they are schooling me on this idea that light moves at the speed of light.
Oh, I get know-it-alls a lot too, but not with that.
Yeah. So sure, you get, I guess people, mansplain at us in different ways. But here's the thing, and I'm about to mansplain, but you invited me, so but here's the thing: is that there is no such thing as objective time, and so how long ago an event occurred depends on the relative velocity of the event and the observer.
Right, it's relative.
And so it's all relative. It's relative. And so in our situation where it's, Betelgeuse is moving at the speed that it's moving through the universe, and we're moving at the speed that we're moving through the universe, there is a time dilation factor that is going on that is off by some number of milliseconds from what if somebody who was moving in exactly the same direction and speed that Betelgeuse was moving, they would see it at a different amount of elapsed time from when the event took place.
Mm-hmm.
And so, but if you're a neutrino that has been thrown out by Betelgeuse and you are arriving moments before the light, and you're traveling at 99.9999 the speed of light, then from your perspective, it exploded 3 hours ago.
Mm-hmm.
Right?
Right.
Because it's just about the velocity. And so when you look at the entire universe, when you're at one side of the universe and we're looking at events on the other side of the universe, literally when those things happened is a difference of 30,000 years.
Right.
Because of the motion of all of the objects, of the expansion of the universe. And so there is no such thing as objective time. And so if a person says, oh, well, don't you know, dummy, that, when we're seeing an event, you can't say it happened now, because when we're seeing an event, it actually happened 640 years ago.
Yep.
That's not accurate, because that means that there is a precise objective time in the universe, and time is all subjective and it's all relative. And so it all depends on the the time that it took for that light to reach you. And so we describe it sort of at the speed of causality, the speed of essentially as fast, the speed of knowing. And so when you describe events in the universe, it is most accurate to just say they are happening now. When we see Betelgeuse explode, it is happening now.
Yeah.
Even though the light did take 640 years to get to us, but it didn't take 640 years to get to a neutrino, and it didn't take 640 years to get to a spaceship that's moving at close to the speed of light towards it, et cetera, et cetera, et cetera.
Right.
And so it's almost like when people clarify that, it's like, yeah, we get it.
Yeah. So whenever I'm using that, again, it's just to explain how, when you look up at the stars, you're seeing old light.
Yeah.
And I think
that's true.
And that's, and that in and of itself is pretty cool. But then I go to explain it of like how that works, what C is and all of that. But everybody's, does that make sense, guys? Well, it is kind of confusing because time dilation is a very wonky thing with like our GPS satellites, right? And that takes into account, other factors.
Yeah. If you hop on a spaceship and you fly to Alpha Centauri at close to the speed of light, at 99% the speed of light, you will experience 3.5 years, and you'll arrive at Alpha Centauri. Right?
Right.
You'll have traveled 4 point whatever light years, and you will have only experienced 3.5 years of time. So if you see an event, you start your stopwatch, and you go to Alpha Centauri, and you watch, say, some presidential election happen, you'll say that presidential election happened 3 years ago.
3 years ago, yeah.
And yet the people on Alpha Centauri will be like, no, that event happened 4 years ago.
Yep.
And the light made the same amount of distance. It's that you experienced different amounts of time. And so you can agree that the event happened, that there was an election on planet Earth and a new president was sworn in, but you will disagree over how long ago that event happened.
Yeah.
And neither of you are right about how long ago it happened.
Yeah.
You are both right. From your perspective, it happened 3.5 years ago. From their perspective, it happened 4 years ago, and both of you are correct.
Yep.
And so to say that it happened 3 years ago, then you've got to ask them to which observer, and what's their velocity.
Yeah.
What is the relative velocity to you? And can you please perform the time dilation calculations for every observer in the universe, including the neutrinos that were thrown out moments before the explosion, please? Or, I get it. You learned that light takes time to move between the stars. So,
Who won the Super Bowl?
yeah.
And wait, okay, we'll take one more question and then I'll let you get back to it. And then we're going to watch a lot of your videos.
Sure. Yeah.
We'll just sit here and watch it. Sometimes Fraser can hang out, sometimes he can't.
Yeah. Oh, Paul Wright says, and not bring into the perspective of the photons traveling at sea with not near 100% time dilation, 100% time dilation. For
It
photons,
happens
time has
now.
no meaning.
Right. Photons don't experience time.
They don't experience any time at all. And is their perspective wrong?
I'm not going to judge them.
No, they have as much of a right to their opinion as when events are happening in the universe.
Yeah, I personally love photons. I really enjoy photons.
I wish we had more photons right now.
I know.
Yeah.
And guys, last week we did a star party, so we're going to start organizing those too around the new moon, and trying to match up with that.
Yeah, I think I'm going to try and do. So I mean, we're already into the moon now. Mm-hmm. And I've been talking to Dustin, and hopefully we'll be able to put some filters on the camera. And if we do that, then we can take pictures anytime. We can look right at the moon
and just say
still be able to see beautiful stuff from space.
Oh, that's good. I'm glad he got one of those because I was wondering if he had some kind of moon filter.
Yeah. So they've got a couple of things. So they have tri-filter, and it blocks out essentially, like, normally when astrophotographers take pictures, they use 3 separate filters. They use their hydrogen alpha, oxygen, and sulfur usually. And then they map red to hydrogen alpha, blue to oxygen, green to sulfur, and then they make a picture. With this, it does all 3 filters simultaneously. So it just makes a photograph that looks like it's full color, but it's actually run through those 3 separate filters, then merged back together. So
yeah,
very cool.
Yeah, very, very cool. And Joe wants me to show you this, so I'm going to put it in Discord. But we did. Okay. This is true. When we were doing a history stream, if you click on that, we found your doppelganger.
Oh, it's totally me. There you go. That's awesome. Alexander III of Russia.
Yes, because we were going over the history of Russia, and we saw that when I forgot who, someone said it in my chat. So
hey, you know what? Before I do go, and you're about to watch a bunch of my videos, this is a good time for people to consider: are they getting value out of this incredible channel? Think about this. Here we are when everyone just wants to talk about Fortnite and Minecraft. Here we are talking about space and astronomy and relativity and time dilation and terraforming basketballs. And how cool is it that Skylias does these streams literally almost every day? She takes time to help educate the world about space, astronomy, physics, history. Can you imagine what a great place this world would be if more people spent more time, learning, thinking about, education, and made that more of a priority? And the only way that's going to be possible is if the people who think that it is important subscribe to Skylias' stream. So if you're watching this, if you've been like sitting on the sidelines and you're like, yeah, this is great, but I'm just going to keep watching for free. Take a second. If you're part of Prime, just give her your Prime subscription for the month. Why not? Just check. You probably haven't even given it to anyone this month. But if you want to go deeper, then you subscribe to this channel and help her continue to do what she does. Because if she can't make a living from this, then it all goes away, and then you just get more Fortnite. You get the Twitch you deserve. So please take a moment and subscribe, and then she'll be able to keep doing what she does.
Yeah, he's so much better at that than I am. See, I'm so bad at pitching it.
I got no skin in the game, so I don't care.
Yeah, you've got a lot of experience with that, and it's so natural.
No, I just don't. It doesn't matter to me. Either way. So I don't have to worry about feeling sad that people didn't subscribe to me. So I don't feel that's a whole separate thing. I'm terrible about getting people to support the things that I do because of all the feelings that you have. The imposter syndrome kicks in hard, and I
Yeah.
mumble requests for people to join the things that I do.
Well, you have a Patreon, and that's listed in the that's listed in the nice link there. Yeah, Fraser is an amazing science communicator, and again, without Fraser and Dr. Pamela, both of them, you guys wouldn't have me.
There you go.
So, well,
wow,
yeah,
that's incredible.
All right.
So before you do, if you want, Skylias just put a bunch of stuff there, but the thing that I think you'll love the most is the newsletter. So down at the very bottom there, it says universetoday.com/newsletter.
Yeah.
It's going out tomorrow. I'm working on it right now. And by that, I mean, I'll be writing it at the last minute tomorrow. But it is, 10 to 20 stories with pictures and me writing about them. There's no ads. And it's really just a complete overview of everything cool that happened in space and astronomy every week.
Yeah, it's an awesome newsletter.
30,000 people subscribe to it, and you will love it.
Yeah. Yep. All
okay,
right.
Well, then now watch some shows, and I'll stick around in the chat maybe if people have questions, and otherwise I might go eat some dinner.
Yeah, sounds good. Well, thank you so much.
All right, it's great to be back.
Yeah, good to have you back. I'll talk to you soon. Okay.
All right, take care.
Bye.
Bye.
All right. Fraser's wonderful, guys. Sorry, I had everything kind of turned down. I have to adjust everything back to normal now. So you guys are gonna have to bear with me. Sorry. Bear with me. I had a bunch of things turned down here. Kill that.